Okay, we're going to take a look at what are known as KP expressions. Most of what you've done in equilibrium so far has used KC expressions, where the C stands for concentration. That is, you're always using molarity and you use brackets. This is KP, where the P stands for pressure. So instead of using molarity, we're going to use partial pressure. So for example, if we had a reaction like this, where we have NH3, which is a gas, decomposing into N2, which is a gas, and H2, which is also a gas. Balancing this reaction, I'll have a 2 there and a 3 there. When I write a KP expression, I include only gases. In this case, everything's a gas, so everything's going to be fair game. And so now in writing that, rather than a C, I use a P. And then rather than using brackets, which indicate molarity, we're going to use partial pressure. So I'm still doing products over reactants, where N2 and H2 will be on top. I'm going to show the partial pressure of N2. I put that in parentheses, times the partial pressure of H2. And since that has a coefficient of 3, we're going to have an exponent of 3 over the partial pressure of NH3, which should be squared. If I generally only use KP when I'm asked to, or when they're giving me ATM values instead of molarity values, but it's usually pretty clear whether you should be using KP or KC. If you have an equation where not everything is a gas, but only some things are a gas. So for example, CaCO3 solid is decomposing, and they're not all decomp reactions, calcium oxide, which is a solid, and CO2, which is a gas. When I write my KP expression, I omit everything that's not a gas. So all that I'm going to be left with is the partial pressure of CO2, and it's raised to the first power. Writing these and working with these is no more difficult than working with KC. It's just an extension of the same concept.